All right, so we are back. This is lecture 8 and iOS continued. So quick warm up to get us back in the swing of things from last week. What did we do last week?
Crash course in Objective-C.
OK, crash course in Objective-C. So quite fast, and realize, especially for those of you for whom C is new or rusty, realize some of those same topics will recur, and by all means ask questions, especially about pointers and memory management, objects and the like. But today we'll actually start looking at iOS programming, not just Objective-C. And Objective-C, recall, is a layer on top of C. So it gives us object-oriented features on top of this older language. To motivate tonight, I thought I'd put up this screenshot of an app that one of our own 76 students last year had worked on since last year for their company, and it just debuted literally this weekend in the App Store for 99 cents. So this is an app with which you can get nutritional information about various foods that you can drag and drop into this wok, create a little bit of a stir fry, click over, and actually see nutritional information about that. So if you're looking to see what an E76 student did just a few months after completing the course last year, realize this is now for sale in the App Store, just 99 cents. So that was among the first downloaders, I think, this past weekend, called Drag and Cook. All right. It's, well, you know, so it could be. They did send me a redemption code. I wasn't sure how to use it. And it was just easier to pay the 99 cents than Google around to figure out how I could redeem it for free. So, and I'm teaching the course. So what does that say? But I'll look into that if I can. All right. So. OK, so yes, this now obligates you to send me redemption codes, because clearly I won't redeem them if you put your own apps in the store after the class. So this is what we looked at last week. So this was Hello World, written in this language called Objective-C. And let's just tease apart some of the pieces of syntax and functionality, even with this trivial little program, so that we can then use it as a stepping stone to much more interesting ones. So up top here, we had sharp import, which in contrast to sharp include, does what for us? Yeah?
It would include those, except it won't duplicate imports.
Perfect. So this effectively does an include, which is to say a copy paste of foundation.h, puts it right there atop the file. But import, unlike include from yesteryear, ensures that that's only going to be done once. And the motivation for that is that if you have constants declared in this .h file, enums, or any kind of global declarations, it would be a compilation error if you redefine that same thing identically elsewhere. So then we have int, main, argc, const, char, star, argv. These we will never need to touch in an iOS application, but we do still need the framework for a main application, because as soon as main gets invoked, it pretty much was going to hand off control in the world of iOS to another function altogether that is only going to return when the application itself terminates. But main will look effectively like this, just a little more interesting, namely this here. So it's wider, how you write an iOS app, but what main does is it simply invokes a function called UI application main, passing in some of those same arguments. But more interestingly, its fourth argument is this syntax here. So we have a function call, C-style, ns string from class. Then we're passing in the return value of a message called class, being passed to app delegate, capital A, capital D. And as we'll soon see, app delegate is a special class that comes with any iOS application to whom control of an application is pretty much immediately delegated. So we're going to see a layering today, whereby main gets invoked as it has been for some time. It passes off control to UI application main. It in turn is going to pass control off to a class called app delegate. It in turn is going to further pass control. And so as you dive into this coding yourself, and as we explore tonight's examples, just remember that there's going to be a whole bunch new function names, method names, and class names, but it's really the process that's going to be one of the most important takeaways, so that when you sit down with a clean slate or with some existing sample code, you can start to navigate it on your own. So I'll try to offer some of those tours verbally tonight. So here's how an iOS application works. So this screenshot here is from essentially one of Apple's how-to documents. And we begin our story up here at the top left, whereby a user taps the icon on the screen, and that results in the program running. More concretely, that means that main gets invoked. Main, in turn, invokes UI application main. UI application main, in turn, loads main UI file. Whatever that is, we'll see what that means in just a moment. But that brings on screen whatever is visually interesting about the display. Then, in turn, after the UI is loaded, The app is initialized. We'll see what that means, but it means setting any default values that you might need, initializing an application in really the generic sense. But then the real magic happens in this bottom left quadrant, whereby thereafter your program essentially sits there in a loop, an event loop, just waiting and waiting and waiting for stuff to happen. And that stuff might be induced by the user interacting with the glass of the screen and touching something, thereby triggering an event that your loop is forever listening for. Or it might be that the clock strikes midnight and your app all of a sudden must do something. And so that will be detected as part of this loop. But for the most part, we'll understand after tonight all of the steps leading up to that, and then how to start configuring this loop to actually do interesting things. Respond to button key presses, respond to sliding the finger across the screen, responding to pinch events and the like. All of that's going to be handled there. And then along the way, we'll find that each of these steps sometimes itself sends messages to other objects to let you know that this step is done. This step is done. Case in point, as soon as the app has been initialized, it sends this message, application did finish launching with options. And this is a rather verbosely named method, but that's going to be a message passed to you so that you can then take control of the application, do any additional initialization that you might want to do, and the like. So ultimately, though, this picture pretty much captures what happens up until the point where things quit, at which point you switch to a different app entirely. All right. So what are some of the capitalized expressions we're about to see? So there's going to be UI application. This is a class that refers to exactly that, the application that you're writing. UI application delegate, in more real terms, this is the class. This is the guy that will be instantiated once for you that's going to take control of the application after that C function, UI application main, gets invoked. So we will be writing some code, though not much generally, in the UI application delegate. Then let me skip ahead to UI view controllers. So iOS conforms to the MVC model view controller, much like Android. And what this generally means is that you're going to have a controller, otherwise known in the iOS world as view controller. And it is what's controlling what the user sees on the screen and also where data is coming from. So it's going to talk to the models that you yourself might write, to a database of some sort, to an internet connection, and it's going to then present information somehow through what we'll call a UI view. And there's going to be all sorts of UI views. At its most generic, a UI view is just a rectangular portion of the screen. But more interestingly, we'll have UI view subclasses like UI button, UI text field, UI label, little GUI widgets that will be layered on top of otherwise this very generic rectangle. And that's how we'll create, among other ways, our user interface. And then we'll see things like UI window, which pretty much refers to the topmost notion of a screen, to the glass. You can think of it in that way, but it has some methods associated with it. So in terms of the mental model to have, much like Android, think of the iOS world that we're about to dive into as this picture here, whereby we are going to be writing lots of code in controllers, more specifically known as view controllers. We're definitely going to be writing a bunch of views, even tonight. And now, by writing views, we'll sometimes do it via a nice drag and drop interface. Doesn't all have to be code, doesn't have to be XML files. And you'll find that Interface Builder is a bit more sophisticated than the Android counterpart right now. We won't dive so much into models just yet, but that, of course, is where data might come from, or how you model your real-world entities. But again, notice what is absent from this picture is any kind of crosstalk between these two. So it really is the controller that's meant to be the brains behind any operation that we're implementing. So templates. When we launched Xcode last week, we saw a whole bunch of templates, and we kept choosing the command line template for Mac OS because we only played with a whole bunch of student demos. And we'll do a couple more just to reflect back on some of the syntax and features of Objective-C that we played with last week. But now that we're going to be clicking under the iOS submenu, we're going to get some more sophisticated templates that are going to give us more code to begin with than just a main.c file. And one of the downsides I felt of learning Objective-C and Xcode early on is that these templates tend to hide certain details, especially details related to the GUI. And so what we'll try to do tonight in particular is make sure that when you start with any of these templates, in particular the single view and the utility application this week or next, that you understand exactly how everything is wired together, what you're getting for free out of the box, so that it's not any kind of dark magic, but so that you yourself could actually take everything apart, or even just start from truly a clean slate, an empty application, and wire things together. So just realize that I think a lot of the mental hurdles that at least I faced in learning this stuff early on was just not understanding what the tool was doing for me, and because it wasn't really telling me, unless you actually read through all of the comments and you poke around a lot. So I'll try to hold our hands during that so that you can more quickly dive in than I once did. All right. So, any questions about where we are headed? Or any questions from last week? Let me see if I can generate some questions from last week. So here is students 8. We didn't see this last week, but and the comments rather reveal what this does. This demonstrates immutable arrays. So an immutable array is just one that can't change. So you have to know its contents in advance. So in this case, let's see what I have done, just so we again can get back into the swing of things syntactically of Objective-C. So for now, we have this thing called auto-release pool. I'm going to use my old school finger tonight since the green is dying. So the NS array here, so this, actually just for warm-up's sake, on the left-hand side of the expression, could someone just say in somewhat technical English what this expression here is doing for us? Just to get the jargon down, especially for those who are rusty or unfamiliar up till last week with C. Yeah? Okay, creating an array of names. So not quite. Let's be a little more precise, only looking at the left-hand side. So right track, but you're over-interpreting the left-hand side there. So okay, so we're declaring a pointer to really an object of type NS array. So what that really is doing is giving me only 64 bits, a memory address space that currently doesn't point to anything. It's some garbage value until the right-hand side of the operation, where we then see the name of that class again, NS array. Array with objects is apparently a method defined inside of there, and it takes an argument, which is a comma-separated list of objects to add by default to this array. So this, put it more precisely, we are passing on the right-hand side of the equal sign the message array with objects with that argument to what or to whom? To the NS array class. So that suggests that array with objects is an instance method or a class method. So it's class method, which means in its header file or somewhere it's declared with the plus sign, which was the syntactic detail we saw last week that says this is a class method or a static method in the world of Java, whereas if it were a minus sign, it would be instance method. And for those less familiar, the fact that it's a class method simply means, again, that we can invoke it without having instantiated any objects yet. So this is more generally known in iOS as, or in Objective-C as, a convenience method. We don't have to call alloc and then init. We can just say what we want, array with objects, and whoever implemented that method actually is going to call alloc in there for us. All right, so nil, this is a common mistake. Silly though it is, you do have to nil terminate any statically allocated arrays in this fashion, so don't leave that off. Xcode will warn you or yell at you if you do not. So at this point in the story, I now have some kind of array structure in memory that's got 2 elements in it. All right, so the next line is just an example of what Objective-C calls fast enumeration. So it's just a loop that on every iteration updates the pointer called name to be the current element in that particular array. And NSLog is sort of our printf-like friend that's just going to print the person's name to the screen. And so just to run this, Command R is going to open the debugging output window on the bottom. And in the bottom here, Window's too big. There we go. On the right-hand side, we see hello Alice, hello Bob, along with the date and time and whatnot and the process ID with which we ran this. So any questions syntactically or functionally on this look back from last week?
Is there any rule of thumb, like when you would, I mean, it seems like when you instantiate it, you always use a pointer, but like it seems like interspersed, sometimes it's a pointer, sometimes it's just the name itself.
Good question. So anytime you allocate an object, either with literally the alloc method or with one of these convenience methods, its return value will be a pointer. So on the left-hand side of that expression, you have to have the star notation saying that this is a pointer. This would not be correct, nor would it compile because I'm trying to assign an address to what is now a statically allocated object, which you just can't do there on the left-hand side. So in short, almost always when we see objects being created or passed around, we will see pointers.
Now, in that place where it says NSLog, and you put the at.
Yes.
At that point there, you're using not a pointer.
So you are using a pointer. So name here is a pointer, and NSLog expects a pointer to be passed to it. So %@ is the placeholder for NSLog that signifies put a string here. And how do you find the string? It will follow that address in memory and go to ALICE to actually display those characters specifically.
You don't have to use the star name.
Correct. So that's a good point to make, especially those who are more familiar with C. Even though we will declare pointers and pass pointers a whole lot in Objective-C, we will rarely dereference them in the manner that you would typically do quite often in C. We might use arrow notation, which is effectively dereferencing, but it will be much less common to see something like this, at least in the context of UI-based applications that we're going to certainly look at today.
But it's effectively still using pointer.
It is. So this says, give me a pointer called name that will store the address of an NS string. And NSLog, if we read its documentation, expects a pointer for that particular placeholder.
But if you pass it as an argument, you still need to use a star for dereference, right?
No. So in short, a reasonable rule of thumb for now is don't do this. Certainly not for the iOS SDK. You will rarely have to dereference pointers in that way. You might start to see that in the context of core graphics and some of the lower level C-based libraries that iOS still uses underneath the hood and also exposes to developers. But what you're seeing now is very common paradigms. You will see the star in the variables declaration, but rarely, though still sometimes, in its actual usage. Yes?
So is the difference in that particular place where you're passing it, passing star name would pass like a number almost, whereas name is like a pointer? Is that the difference between the two?
It is. So because an object takes, so a primitive like an int and a float and a char takes up a finite amount of space in memory. It's typically 8 bits or 32 or 64 bits, something along those lines. And when you declare it with int x, you are allocating those 64 bits in that case, and a symbol called x is being stored somewhere so that it's a mapping from x to those 32 bits. When you allocate an object, though, two things are happening. For instance, on the left-hand side here, we are allocating 64 bits for the pointer, whose purpose in life is only to store the address of something in memory. And the right-hand side of that same expression is what's actually allocating the object, and it might take up 10 kilobytes or 10 bytes or a megabyte. We don't know. It's a variable sized object, certainly in this case an array. So what is invariant is the size of the pointer. And so for efficiency purposes, we'll almost always pass around objects by way of pointer, because then you can just get away with just passing 64 bits around, which would fit in a CPU's register for efficiency, if that helps. Yeah?
So then once this loop is done, our name pointer is pointing at the nil. So if we want to go back, do we have to move it back by, like, how do we roll that back?
Good question about nil. So this is a feature that was added, I believe, to Objective-C 2.0, fast enumeration, which just means you can use this very nice succinct syntax of for and the keyword in. It will not iterate one too many times to nil. It will stop after Bob. The next time you use fast enumeration, it will just start over at the beginning. You don't have to worry about it being any kind of enumerator or iterator that you have to rewind yourself. It's only within scope within that loop. So it works in the way you would hope. All right, so let's look at two final student examples, one pointer example, then we'll start creating some GUI stuff. So in students 9, we have a slightly different type of array, that of a mutable array. So if you don't know in advance what you might want to put in the array or how many things you want to put in the array, you need a mutable array. And for efficiency purposes, Objective-C allows you to distinguish between the two. If you know in advance the size, you can save some CPU cycles and memory down the road by just committing to a fixed size. But if you don't know, it needs to be mutable. So making this distinction in code is important. So up top, this time, notice that I have allocated on the left-hand side, a 64-bit pointer. And I keep saying 64 bits because all of Apple's Macs these days are 64 bits, which means if you're unfamiliar, a 64-bit Mac means it uses 64 bits for its pointers, among other things. So here we have 64 bits called students that's going to point to a mutable array object. On the right-hand side is how I have allocated it. So this is actually shorthand notation for another way. I could also write this same line in a functionally equivalent way like this. So that too would be a very common paradigm. So what's the difference here? And it's yelling at me because I've done it now twice, which is bad. So what's different here is that on the second line that I've highlighted, you're calling the traditional alloc method, which is a class method in the NSObject class. So any objects that descend from that get this guy for free. And then I'm calling init. I don't know what init does, but it might do something. And the paradigm in Objective-C is you initialize your objects after allocating them, almost always. Why not use this approach? Well, it's just more to type, frankly, among other things. And this is why there are these convenience methods that up top there are convenient and that you can type less. And historically, there were also some memory implications whereby you had a little more control over when this object is allocated, and you had less control over when this one was allocated because of a feature known as auto-release. But let me just wave my hands at that detail until we peel back that layer. So for now, we're calling the array method, which simply returns to me a variable-sized array, initialized probably to 0, but who knows? Maybe they anticipate some number of objects. So now let's add Alice to this. So I'm instantiating Alice, which I didn't do before. In the previous story, Alice was just a string. Now she's an object. And Alice has a name and an age. So per last week, the name of this method is student with name and age. That's how we would describe it. So it takes 2 arguments here. How do I add an element to an array? So the student's variable is a pointer to an NS mutable array. So we can't really just use square bracket notation, sort of C style, whereby we just add something to it. We need to pass a message to the object saying, add this object, known as Alice, to yourself. And it's really a vector. It's going to grow itself dynamically to fit the objects that are added. We're doing the same thing with Bob, calling him Bob and age 21, adding Bob. And then just for kicks, to prove that this works, I'm greeting each student iteratively here. All right, so almost the same as before, but this time mutable. And then lastly, we have this one here in our 10th and final version, where I actually decided, you know what, I'm going to implement an instance method myself. So let me go into my files up here. Notice that there's 3 of interest, main.m, student.h, and student.m. So in student.h, let's see what we have here. I have the interface called student. So this is a class declaration here. Does it have any instance variables? Arguably a trick question. OK, so I'm seeing some heads shaking. So, sorry?
Age and name are
Yeah, so it doesn't have any explicitly declared instance variables, but thanks to the magic of properties and the synthesize keyword that we saw last week, those IVARs, instance variables, will be created for me, thanks to the synthesize keyword. So if I had explicitly declared some of them, they would be up here in the curly braces. For instance, I might have literally int underscore age. But that's just not necessary. And in fact, it's just one more thing to type. It's one more thing to keep track of. So we can even eliminate the curly braces altogether if we ourselves don't have any instance variables. I'm sorry? They will be when we look at the M file, where we will see the call to synthesize. So down here, let's fast forward to these things. What are these things here? So these are just method declarations. So they don't strictly need to be in the H file. And in fact, as our examples get more sophisticated, we're going to start removing stuff from the H files that just don't need to be there. H files, header files, are generally meant to be imported by other classes, other objects rather. And if you don't need to advertise to the world your functionality, you might as well make them private. And private is not going to be enforced as rigorously as it is in a language like Java, but we can at least hide some of our implementation details from other classes and other developers by putting it in our M files instead. But more on that down the road. So these are two instance or class methods? OK, instance because of the hyphens, which means you can call them only after you have a student object. You have two arguments of the first. ID means what? Yeah, so it returns a pointer to an object, or nil could be the special sentinel value if it just initialization fails. So now above that, we have two properties. So let's come back to those properties in just a moment. In student.m, we have a couple things. Synthesize, which we'll come back to as part of the properties discussion. And now we have a few methods. So one, we have an init method. So how is this thing working? Well, the init method, I decided apparently, if you try to initialize a student object and you don't give me a name or an age, I'm going to arbitrarily assume that it's John Harvard, who as of this year is 403 years old, just because. So that is my init method. If I didn't have this, everything would still compile. It's just I would have nil values for nil value for name and 0 value for age because they won't have been set previously. So the more interesting one is this. So anytime you implement your own initialization method, whether it's whether it's called init or something more complex like init with name and age, you'll very often see this paradigm here. And actually, I can clean this up syntactically, whereby this is no longer necessary. So before you yourself presumptuously start initializing the object, you better ask your parent object, do you need to do any work on this object first? And you can do this by invoking super init. So that invokes the parent class's implementation of init. Who's the parent in this case? So is NSObject. Now, I don't know what it does, but my agreement with my ancestor classes is that I'll at least call the parent's constructor, just in case he has to do something interesting. So just in case something goes wrong, he might return nil, in which case I better not proceed to keep touching this object. But if all goes well and this is non-nil, so the if condition evaluates to true, I'm going to go ahead and update my age and my name to be whatever was explicitly passed in. And then, important, I return myself. So the init method ultimately returns a pointer to the object itself. So you can think of this like an explicit constructor, but the user has to invoke it himself. So the greet method, what's going on here? So the greet method apparently can be called if I want an object to say hello to the world via nslog. Notice the placeholder for an ns string, placeholder for a string, and now this syntax here. So a couple points to make here. I could have written underscore name and underscore age differently. What else could I have plugged in here and here to make this work? Perfect. So self.age and self.name, because that would be an allusion to the properties that we declared earlier. And I can also be ever more explicit, whereby I could say, you know what, return the instance variable called underscore name and underscore age within myself. So here is the one exception that I was alluding to earlier in our pointer discussion. The arrow notation, recall, is simply syntactic sugar for star, dereference a pointer, and then go inside of that structure. So this you will rarely ever type, if only because it's just ugly looking and the arrow notation is cleaner and it's a little less to type, just a little more readable, but this is still happening underneath the hood. Or we can do the property approach where I can say self.age and self.name. So in terms of design, why do one or the other, do you think? There's no one right answer here.
With age and name, you can go directly to those objects.
Yeah, so I'm inside of the student object. I know because of my synthesize keyword that the instance variable that will be automatically synthesized, that is created for me, to back the property called age will be somewhat arbitrarily underscore age. Could have been anything. Could have been foo. It could have been, if we leave out the equal sign, it could just be age itself. But convention is to create an instance variable with an underscore, just so it's more clear that it's an internal sort of private variable. And what's advantageous then of this syntax, or what's advantageous about the original syntax with the underscores is what? Yeah, I'm saving a step. I'm not spending some CPU cycles calling a function, calling the method, which in this case would be the getter. Now, arguably, this is safer because what if these variables aren't set and you don't want to get direct access to nil or to 0? You might want to return some default value. Well, if you at least use a property in this way with the dot notation, what is this actually equivalent to? Self.name is doing what functionally per last week? So it's invoking the getter or the accessor, so to speak. And where did that method come from? I didn't write any getters or setters today. Synthesize, right? It just generates it for it so we don't devolve into Java where we have to write everything ourselves. So this really is just, again, syntactic sugar for this. Self is a pointer to an object. Name is the name of a method. It's a getter that was automatically given to me. So that's really what that is. So why do one or the other? Well, just the dot notation has certainly come into vogue within Apple programming guidelines. And so it's just a little cleaner to read. But it is nonetheless invoking a method. So in short, which is the best way to do it, or most conventional these days, especially that we have gigahertz processors, and just so that you yourself don't forget about some special case you implemented in the getter or setter, which recall You can implement manually if you so choose. This is generally what's most smiled upon.
Are these still called messages or methods?
So really, it is a message when you're calling it. So you pass a message to an object. I and many people still say method, but really these things are also called selectors. But methods is reasonable. But when you use it, you're passing a message whose name is what we would call a method. All right. So in the M file, how are we using this thing? Well, we are allocating Alice, and as per convention, we are initializing that object all within the same line with the nested brackets. Just to be clear, we don't have to do it all on one line here. We could do a little more pedantically this. Clean up that line, and then we can say Alice in it with name. So these two lines, whoops, need my close quotes, close brackets. Those two lines are equivalent to this, and the former, the one that I'm currently highlighting, is the most common, to just do it all in one line, alloc and init.
Or we could do dot notation assign the variable.
So you could, if you don't have an init method, you could certainly just say something like alice.name equals quote unquote Alice. That's fine too, but in terms of design, especially if conceptually you don't really want an object to exist without a name or an age, then it's probably best practice to use the initializer and not use explicit setters, certainly when you don't have to in this case. And then Bob is created in the same way, and at this point it was just getting boring just printing out Alice and Bob, so I just stopped. So nothing actually happens in this program except to introduce this explicit initialization routine. So that's again it on our crash course in Objective-C. You now know everything you need to. Any questions? Yeah?
The header file, I'm not sure if you're going to go over this copy.
Oh, sure. Let me say something briefly now, but we'll see this in more detail. So these two properties do a couple. Our use of properties does two important things for us. One, it allows us to use synthesize, which means we don't have to write getters and setters ourselves. And two, it allows us to, what's the other value add of properties? That was the first value add, but nice try. Number two? Yeah.
Auto-generate lower level management code for the data going to those variables.
Fancy way of saying getters and setters. But nice try. Anyone else?
That template thing or like a type of class?
Not template. It's simpler. It's almost a silly feature to crave so much. It's just the sugar, right? It's the dot notation that you're allowed to use as a result of using properties. So that's it. We get the dot notation, and we get the potential for automatic synthesis with the option, as we saw last week, I can still override the setters and getters myself if I so choose, though that's not often necessary. So what do these parentheticals mean? The parentheticals control the implementation of the getter and or setter that will be created for you when you call synthesize. In other words, you can implement a getter very easily. You say the ivar gets the argument that was passed in. Sorry, that's the setter. You can say the ivar gets the setter that was passed in. But what about in multi-threaded code where you actually want to take a lock before you actually mutate a variable's value? Well, you might have to have some wrapper with a semaphore or lock. Or for those unfamiliar, you might need to encapsulate the setting of a variable in some kind of transaction, keeping other threads out of it so that they don't both try to update it at the same time. Well, this is definitely code I'm not going to want to write all the time lest I get that wrong, and it's certainly code that I would otherwise be copying and pasting a lot. So the parenthetical here are hints to Xcode telling it, or really the compiler, what kind of setter and getter to generate. Do you need thread-safe code, locks and so forth, or can we skip that part of the code generation? And that's what non-atomic or conversely atomic refers to. Read-write or read-only, you can probably infer what these do. If it's read-write, synthesize will give you a getter and setter, and if it's read-only, synthesize will give you a just a getter, no setter. So that's sort of a nice and descriptive. Assign and copy and some other keywords we'll see, namely strong and weak. We'll see those more. So let me wave my hands at those. But those have to do with how pointers or how primitives are handled. And whether a copy is literally a copying of bits. Is it a copying of the object? Is it a copying of the individual characters in the object? We can have different semantics for the notion of what we just call copy. So we'll come back to this. But that's what it's referring to, the synthesis of getters and setters. All right, so quick little visual quiz time. Here is a little Mac program called swap failure that fails to swap two variables. But let's see if we can't tease apart why this actually fails, just so that we're all on the same page when it comes to pointers, so that we can now start taking them a bit more for granted. So at the top, I have a function prototype. In C, this was necessary because if you're going to call a function, you better teach the compiler that it exists up top in a header file or before you actually call it. Here's my main function. I have an int x and y initialized to 0 and 1 respectively. I'm using printf just to tell the world what the values are. X is 0, y is 1. Then I claim swapping x and y, ... Then I am calling a function called swap, passing in 0, 1. And then I'm announcing failure. X is something and y is something. And as failure suggests, x is still going to be 0 and y is still going to be 1, even though I very convincingly called the function swap. So why does this fail? Does anyone want to tell the quick story in English as to why code compiles, code runs, but it fails? How about in back? Yeah.
Because it's passed by value.
Yeah, so it's passed by value. So what do we mean here? Well, when we call swap and pass in x, y, x and y are primitives. They're not pointers. So how do you pass in primitives? You literally make a copy of those bits. So we're going to pass in 64 bits representing 0 and 64 bits representing 1. And then swap is going to call those same copies of bits, A and B, but this is irrelevant what they're actually called. It then proceeds using these sort of CS101 style code to swap those values, A and B, but then it returns. And as soon as it returns, what happens to A and B? They're gone, right? So when you call functions in C and also in Objective-C, there's also this stack, literally stack of memory frames being allocated. So X and Y exist here. When you call swap, you create copies of them here. You actually do swap them, but then this frame gets thrown away as soon as swap returns. So you've swapped values, just the wrong values.
If you put might be worth noting, if you put a print in the function, it
Yes.
swapped for that moment in time.
Exactly. If I print out A and B here, absolutely. They are now 1 and 0 instead of 0, 1. Unfortunately, as soon as I hit this thing, I throw those values away, and X and Y remain unmutated. So what's the solution in a buzzword? Pass by reference, pass by pointer. So how do we do this? Well, in swap success, as the name suggests, the syntax unfortunately gets a little uglier, but paints a picture as to why this is now necessary. So I had to make two syntactic changes. What's the first one that jumps out? So the ampersands in the swap call. So rather than passing x and y, I'm doing ampersand x, which represents, or which means the address. Give me the address in RAM of this variable, and it's going to be some random number addressing my 0 to 2 gigabytes or however many megs I have. Same thing for y. And now swap, and this is one of the stories we told last week, swap now takes a pointer to an int and a pointer to another int, calls those pointers A and B. So here too, though, I don't want to swap A and B now. What do I actually want to swap? The addresses. Or not the address, what's at those addresses. So I need to dereference A and B in this case. So in this C case, I need to say, well, give me a copy of what's in address A, or rather what's at address A. So I follow the pointer and go to that memory location, and it's the number 0. And what is A itself? What's the value of A? Some like OX12345. It's some random address in RAM. But star A is 0 because it's mapping to X. I put 0 in the temp variable. Then I say go to A and put what there? Whatever's at B's address, which means put 1 into this variable storage space. Then go ahead and store what is supposed to be at B, what you put in temp, thereby literally swapping those values. So if I now print out A and B here, and take me literally, what do I see if I print A and B?
A and B's. See the add.
Yes, I see literally the same addresses that I passed in originally. But if I print out star A and star B, I see 1 and 0 now, respectively. I see the swapped results, and those results will propagate up to the other frame, main, because I actually went to that address and changed the value. So in terms of my layering hands, main is here, as are x and y. I call swap, but I have informed this guy what the addresses of x and y are here in this lower frame. So when we do star A and star B, this frame here is essentially peeking his head down into this frame and changing these two values so that when he disappears, it's those values that were actually changed. Yeah?
So I understand why this works. Why wouldn't swapping, I mean, A and B, if you just use A and B without the stars, wouldn't you be exchanging the memory addresses? So instead of exchanging what's at the memory addresses, couldn't you just exchange the memory addresses themselves and then they'd just be pointed, you know?
Good question. So why do we have to dereference A and B? Why can't we just swap A and B? Because at this point, we could just swap the addresses. So you can do what you're proposing, only if you pass in a pointer to a pointer. For this exact same reason. Because when I pass in ampersand x and ampersand y, what am I getting? I'm getting the address of x and address of y. But per the original story, what is swap getting? It's getting a copy of the address of x and a copy of the address of y. So sure, you can swap those pointers, but you're not actually changing the original values. Unless you do, and you can't do it here, ampersand ampersand x, which doesn't make sense. But you need to do the equivalent of that. Give me a pointer to that pointer so then I can dereference that. And pointers to pointers do exist in C, but they're generally in the context of arrays, not you can't take the address of just some random location in memory because it's not a piece of storage. It's not a variable, rather. All right, so just to prove that this wasn't all a wave of the hand, let me actually run this thing. And indeed, these two values were swapped successfully this time. And take my word for it, in the previous version, they weren't. So all of this was necessary. All right, so that is our final crash course in pointers. Now let's take a tour of some of these here templates. And we'll start with the simplest of the bunch. So I've just loaded up Xcode. Again, in the project spec for setup for iOS, you'll be walked through exactly what to download, what you do need to get, what you don't need to buy. Nothing will require money for this part of the course unless you actually want to submit to the App Store ultimately. And we see a few templates. So first, realize last week and a bit today, we poked around under macOS. Today, we start doing only the things under iOS. So we have a few templates here. Empty application is really a skeleton of a starting point. Generally, you'll find it more helpful to start, for now at least, with single view application. And for Evil Hangman, utility application. As an aside, we did post a bit early the spec for the staff's choice, which we'll talk about a bit today and also more next week. There will also be a walkthrough as scheduled next Wednesday. But just in case you're really raring to go, even though we haven't covered all of the material for it, you can dive in a bit early or at least bring yourself up to speed on it. And that's going to be a utility application. Tabbed application is the thing with the buttons at the bottom of the screen. Master detail application refers to a table view now. That's kind of evolved its definition in Xcode. But it's a table view where you see a column of entries. You click on one, and then everything slides over. You touch again, it slides over like an inbox. OpenGL Game does what it says, and a page-based application is the sexy little page curl if you want to sift through the equivalent of a book. So for now, let's start with single view application and focus in particular on what we get out of the box, but more importantly, what Apple has done for us so that it's not just a magical starting point. So I'm going to go ahead and just call this demo. For a company identifier, this is just a convention. I'll say Edu Harvard extension, which is the reverse of a domain name that we can claim some kind of uniqueness for. Class prefix, I'm going to leave blank. For device, for now, I'm going to generally just pick iPhone because it fits nicely on the screen, but you'll see that you can certainly target iPads. You can target both with multiple views. Storyboards, I'm going to leave blank for now. I am, and you should too, check automatic reference counting. This was one of the most compelling features introduced at WWDC last summer, which is part of iOS 5, which means the memory management conversation we had last year this time was much more complex than it will be this time. We'll still have it, and we'll still talk about what reference counting is, what's going on underneath the hood, but the introduction of this thing called ARC, automatic reference counting, means we humans can think a lot less about memory management, which is probably the way it should be, because OSs and compilers should be getting smarter than humans so as to do this kind of thing for us better than we ourselves could. And unit tests we'll leave blank for now, but that will allow us to have some prefabbed unit tests generated. I'm going to go ahead and just store this on my desktop. You can check or uncheck the Git repository if you like using Git. Let me disclaim that Xcode's Git integration is crappy at the moment. It's buggy. So cloning doesn't always quite work as well as it should. The built-in GUI doesn't quite work as well, but know that you can still use Git quite fine, but often I and some of the TFs have been resorting to the command line still. If you're a Git user, in theory it's supposed to work, but even we noticed a few bugs in Xcode 4.3, so just buyer beware there. Not to say don't use Git, but just beware using the GUI for it. All right, here we go. My first iPhone application. I don't even want to know what any of this does. I'm going to go ahead and Command R, and voila, I'm an iPhone programmer whose phone is still in Spanish mode, actually. So I will fix that in just a moment. But this is the beginning of our application. And what am I seeing on the screen besides nothing? A view. So the rectangular defaults that I referred to earlier, we do see a view. It's just I haven't put anything of interest there. So the only things you really need to know about the simulator is, one, it's much better than Android emulator, and it's easy to get up and working. You can rotate things very easily to simulate various orientations, depending on what your code supports. You can simulate different versions of the simulator in terms of the hardware. The Retina display or not, the iPad or not. On this screen, again, I'll typically use the iPhone. We can simulate memory warnings. So once you do dive into the staff's choice of project and student's choice, you'll want to, once your code's working, start trying to break it. And the easiest way to break it, frankly, is going to be to send a message to the phone saying low on memory, because the OS will presumptuously start evicting things from memory, oftentimes UI elements, buttons and windows that aren't viewable at the time. So anytime something's off screen, it is vulnerable to being punted from RAM. Problem is, if you, the developer, don't anticipate that, when that screen comes back into view, you're not going to see your buttons or your views or your data anymore unless you've implemented the right methods to reconstruct that view. So this is going to be very common and a very useful thing to use. And now, since I left my phone in Spanish mode from earlier, I'm going to just reset the whole thing, which will delete all of the stuff that I've installed on it from the device here. And pretty much the simulator can do almost anything, certainly for the staff's choice of projects that you might want to do in a real phone. Just you can't use the accelerometer and a few hardware-specific features. But otherwise, it is a wonderful tool. All right. Any questions before we do our deep dive into what we see here? Yes?
Java comes with a very rich set of standard libraries.
Mm-hmm.
And there are also easily available modules for things like XML parsing.
Mm-hmm.
What's the environment for iOS like, and where do you get modules like XML parsing?
Good question. So just for the camera, whereas Java comes with a rich set of collection classes, utility classes, and the like, where do you get such, or is there such for Objective-C? So the foundation class that we started using, albeit only by scratching the surface, is where a lot of that functionality is. NSArray, mutable arrays, sets, dictionaries, and the like. There are also additional classes. There's JSON parsers, XML these days. So especially with iOS 5, a lot of holes were filled in. So it's a very rich SDK overall. And the only thing, to be honest, in the past year that I've manually imported that I needed was a JSON parser, but the latest version of Xcode added, or the latest version of the SDK, and in turn Xcode, added that. So I no longer need to use a third-party thing. And you'll see, even though by default in a moment, you won't see a lot of the libraries that are available to us simply for efficiency purposes. Right now, we're only given UIKit, Foundation, and Core Graphics. And we'll tease apart those before long. You can add more to that. SQLite is a built-in feature if you add it so that you can link against it. So in short, I don't think you'll find yourself wanting for many features. Other questions? All right. So at first glance, Xcode's a little overwhelming, especially with all of the various settings that you can tweak, but you generally don't need to tweak any of them. And I will say from personal experience, I am a huge fan of Xcode itself as an IDE. I wish it were more versatile for even other languages, since I've never really been a fan of Eclipse or NetBeans or the like. It's one of the best, it is probably the best IDE I've ever used. Now, the first time it crashes on you, you're going to wish I hadn't said that, because it does crash once in a while, but not as much as Eclipse historically has. So hopefully that's a selling point. So let's see what's going on here. In short, generally, we won't need to touch this, at least not at first. Focusing your attention on the files that you were given out of the box for free is perhaps the best starting point. So let me expand all of these folders. Even though they look like yellow folders, they don't necessarily map to actual folders on the file system. They're what Xcode calls groups, so that you can logically cluster files together, but on the file system, everything's in one huge directory quite often. All right, so what's of interest here? First, let's start crossing off some of the things we don't really need to care about just yet. So from the bottom up, demo app doesn't exist. I haven't compiled it for a phone, actually, so it's in red, just meaning it's not yet built. These things are libraries that we might link against. You can double click in there and see what's in these libraries, but you generally don't need to. It's much better to look at the actual documentation. So this is to say, we can pretty much start closing our eyes to what's inside there. Now, how about supporting files? Here's main.m. This is what I promised would be the guts of an iPhone application, and that's identical to what we saw earlier in black and white on the slide. But notice, again, it invokes some kind of mention of app delegates, and now, thankfully, we see mention of that at top left. So we'll get there in a moment. As for these other things, PCH file is a precompiled header. It's essentially a header file that's automatically prepended to your files. You'll rarely need to add stuff there yourself. So for tonight, we're going to say goodbye to it. Well, don't delete it, but we don't need to look at it. Info plist.strings is where you can put some localized versions of various strings. So for things like English or Spanish or the like, you can factor those strings out, much like you can in Java, into central text files. But for now, we'll keep things simple. And then we have demo info plist. So demo recalls the name of the app. And here we get some system-wide preferences that are set. For instance, we see some kind of mention of what device orientations are supported, this way, this way, this way, this way, or the like. If I want to add certain settings here, I can simply hover over it, click plus, and frankly, the only one I'm in the habit of ever adding like this is status bar is initially hidden. So if you want to hide the clock and the battery, you can simply come in here and say yes, which is again a Boolean value, and so forth. Now you can also do those same things in code. This is just one way of storing those same types of settings in a file called a plist, property list, which as an aside, it's just an XML file underneath the hood. So this very pretty row-by-row presentation we're seeing is just the GUI simplification of an XML file. And you don't need to edit the XML file itself, but we'll see property lists in the weeks to come as a general storage mechanism. All right, back over to the left. That's it for supporting files. You will never need to. That's a safe statement. Never need to edit main.m. So for the most part, I'm going to also close this one to further narrow the scope of what we need to care about. And now we can start to tell our story. So let's tell it in the order of the user interface first. In viewcontroller.xib, we have what's called a nib file. Even though it's xib, it's historically pronounced nib, being next step interface builder. When the IDE became Xcode a few years back, nib became xib, but it's fun to say nib still, so it's xib is a nib file. What is that? Well, it too is actually an XML file. It is the serialization in XML of a user interface. What does this mean? We, in a moment, can start dragging and dropping things like buttons and text fields and scroll bars and the like. Those can all be represented with pure text in XML, and that's ultimately what this WYSIWYG editor is doing for us. Historically, and in textbooks, you might see this thing called Interface Builder because it used to be a separate application. Now it's part of Xcode itself, but we're about to see things like IB outlet, IB action, and IB more generally. It's referring to Interface Builder. It just refers to the drag and drop capabilities of Xcode. So at first it can be a little overwhelming with how many features this thing comes with, and sure enough they're all hidden under this icon here. As I think I mentioned last week, a lot of Xcode looks simple, or can look simple, very iTunes-like, because you just close all the windows that are otherwise overwhelming. But if we click the view on the right-hand side, we get a whole bunch of things called inspectors. And this is similar in spirit to the kinds of properties you would set in Microsoft Word or Photoshop or the like, and some more technically interesting ones. But a lot of the fine-grained configuration happens over here. And we also have like a toolbox of sorts. Down here, for instance, we see a list of objects. And these are all of the various UI widgets that come with iOS that we can simply drag and drop into place. So for instance, I can drag a label here and plop it there. And like Photoshop, you get nice little grid lines. I can expand this here, and you'll get suggestions as to how far from the edge of the glass you should probably make things. Over here, I can center it in this way. I can go ahead and increase the font size if I want, and so forth. So fairly self-explanatory when it comes to the aesthetics of these things. But how to control the content of that label, we'll soon see. We can certainly do something simple like hello, comma, world. And it looks like this now, and I'll recenter it here. And indeed, if I go ahead and recompile this with Command R, it's going to automatically run the simulator. Now, I finally have a much more interesting iOS app. I could drag and drop some other UI mechanisms, a round rect button like this. And I can say something like hi. I can recompile this. And in the simulator, I can start clicking on this actual button. Of course, it doesn't do anything because I haven't wired up that little widget to any sort of code. So we'll see that thanks to Interface Builder, making GUIs, at least fairly simple GUIs, is actually quite easy. And we can make them look much sexier with little embossing or shading and gradients and whatnot. But out of the box, we can get a whole lot of these widgets simply by dragging and dropping. So why don't we go ahead and take our 5-minute break here. And when we come back, we'll start wiring this together with actual Objective-C code. All right, so we are back, and we continue our tour of where we left off. So we were just looking at viewcontroller.nib, which little, XIB, Xcode Interface Builder, contains what appears to be one or more views. And just to be clear as to the views here, notice that it is indeed a view hierarchy. If we click on the big rectangle here, the gray box, notice that view over here under objects gets highlighted, and that's indeed the default rectangular view that we get for free by having this thing in the first place. However, once we started dragging and dropping, notice that we got this label and this button that are actually nested underneath hierarchically that view, which is to say they are children of that view. So a theme in iOS view programming is going to be that you have one parent view typically, inside of which are other little widgets, but that are really layered on top of that. And in turn, those can have things layered on top of them. But generally, it suffices to drag and drop and worry a little less about these things here. We'll see in a bit what files owner is, and we'll see the notion of a responder throughout the discussions this week and next. So where best to turn our attention to? Well, where did this program start? We had main in main.m. It called UI application main. It in turn mentioned as its fourth argument what? App delegate. So let's take a look at app delegate. So this is apparently one of the entities to whom control of the application is delegated. So let me close that view over there, and let's see what's going on inside of this file. So we have some comments up top that Xcode generates by default for us. We're importing uikit.h. What's that? Well, this is the user interface kit that gives us access to things like the text button, the buttons and the text views and the scroll bars and the like. So that's simply giving us access to those related classes. This is what at class, this as I mentioned I think last week, there is an at class keyword, but it's what's called a forward declaration. This is here simply because we're about to mention down here the word view controller before we've actually implemented that class, because it's in a separate file. So this simply means you're going to see this later in the code. And it keeps the compiler happy, but for now let me just kind of wave my hand at that. So now's where we're seeing some slightly familiar stuff, even though it's a little more sophisticated than just student classes. So here's an app delegate class, as implied by the at interface declaration. It descends from which of these classes that follow in purple? So UI responder. So it descends from UI responder, which is some Apple-provided class that apparently can respond to stuff. And that kind of makes sense intuitively, because it has to be able to respond to everything that's going on the screen. And the angled brackets denote what? It's a protocol. So this class is called app delegate, but that's fundamentally meaningless. It could be called foo. But the fact that we're specifying in angled brackets that I am making a commitment to implement the UI application delegate protocol, that means that I implement 0 or more methods from that protocol. And I say 0 or more because a protocol can have both required methods that anyone who's implementing the protocol must implement, or it can have optional methods, which you can, but you don't strictly have to implement. So this just says that I'm implementing all of the required methods, if any, inside of that delegate protocol. So what else do we have inside of this class declaration? Well, we have two properties. One is window, one is view controller. And you can think of these, oversimplification. One of those is a pointer to the physical screen, the glass, and the other is a pointer to the guy to whom I'm going to further delegate control of this application. The view controller, or controller more generally, is going to be the guy in charge of the actual application. And we'll see that inside of the app delegate class, there's still code. And we ourselves might write some code in this class. But it's typically fairly low-level code that has nothing to do with your UI or your models or your data. Rather, it has to do with what do you want to do when the user hits the home button and you get backgrounded? What do you want to do when a call comes in and you're interrupted? Do you want to pause the game? Do you want to save state? Do you want to do anything along those lines? It's the lower-level functionality that's inside the app delegate. It's in the view controller that your actual game or program is typically implemented, at least as a starting point. You can have multiple view controllers. So let's now look at the, and just to tease this apart, notice that we have mention of strong here and strong here. That refers to pointers. Properties that are pointers can either be strong or weak. In older textbooks and online references, you'll see mention to retain and copy as well, but we can still use copy here. But we'll discuss memory management in the examples in weeks to come. So for now, just know this has to refer to pointers. And I don't see read only or read write. Does that mean there is no getter and setter? No, it just means these all have defaults. The default is atomic, which is why you see non-atomic so often around the place. Read-write is the default. So we'll get both our getter and our setter. So now let's look inside of the app delegate itself. One of my pet peeves with Xcode, frankly, is that they clearly have different people, or at least the one same self-inconsistent person writing the templates, and you will see stylistic differences among their templates, which I find being fairly anal, infuriating. But realize that they are functionally correct if stylistically inconsistent. So, and by this I mean white space and naming conventions and just stupid stuff. All right, but that's just a little pet peeve there. So what is inside of the app delegate? One, an importation of its own header file. Another, it's an importation of the view controller class, which we're going to make heavy use of coming up soon. At implementation means this is the implementation of an at interface that's presumably in the header file. So it's going to be an implementation of this class here. Notice what we don't do is we don't re-mention the parent class and we don't re-mention the protocol. That's all in the class's own declaration. So this is the same thing as we've seen before, synthesize window and view controller, whereby we are automatically getting getters and setters for the window property and also for this view controller property. So that's nice. And we can also use dot notation. So now this is the method that is called when UI application main itself is called in main, the function. So again, we have main, UI application main, we have app delegate, but specifically we have application did finish launching with options. And that's a bit of an oversimplification. There's other stuff happening in there, but this is the next point at which we ourselves have control. So this is the first opportunity we have programmatically to write code now. It doesn't belong in main.m. This is the first chance we have. And indeed, as the comment says in the template, here's an override point for some customization after the application's launch. So what's going on in here? One, first we're allocating something called a UI window. And again, you can think of this as the glass screen. We need some way of talking to the physical interface of the device. Notice that there's a few nested calls here. We've got alloc, then init with frame. A frame is a rectangular space. UI screen refers to, main screen refers to the default screen. So you can have, thanks to Wi-Fi, you can have secondary screens nowadays from iOS devices. You can have VGA output or DVI output. So main screen refers to the physical glass, but there could be secondary screens for VGA projection and the like. So this is just telling the compiler, get me the bounds of the main screen and allocate the window within those bounds. So it's just boilerplate code that we need to have at this point. We'll skip the comment because we're not going to write any code in this particular template just yet. The next line of code is self.viewController gets what? Give me a viewController object, initialize it with the nib, whose name is viewController.something. It is .xib by convention, and bundle is nil here by default. Typically, bundle refers to different context, but the application bundle itself, all the files that you compile together and create one executable program. It's like the .app directory if you're a Mac user, what you see in the world of Macs. So this is just giving me a view controller, and it's initializing it with this nib. So that's, recall, the file we looked at previously. Lastly, here we have self.window.root view controller. So a window needs to have something to display. What's the window going to display? Well, it's going to ask whatever the root view controller is to do its thing. show me whatever rectangular shapes you want to show to the user. So that pointer here is a property. How do I know to do this? Well, if I looked up the documentation online for the UI window class, I would see that that has a property called root view controller. And if you're curious, you don't have to go Googling. We can hold Option. We can hover over this symbol here, root view controller. Notice that it becomes dashed underlined in blue. I can click that. I get a nice little cheat sheet as to what this is. Yep, it's a property, UI view controller pointer, retain. So this is sort of legacy mentions that are still in some of the documentation from iOS 4. And the root view controller for the window. So this is the guy that's going to be in charge of the game or the program, whatever it is I'm going to implement. If you click the book here, you'll see what will become a familiar interface, which is that of documentation. Organizer is the program that just ran, which is built into Xcode. This is just a fancy piece of Chrome around an embedded web view nowadays. All of this stuff is on the web, the same documentation. So you'd see the same stuff via Google, and notice that I see root view controller, a description of what it is. In Courier font or whatnot, I see exactly what its declaration is, then a nice little discussion, and so forth. Yeah?
The book didn't actually open the documentation. Is there another way to get to the documentation?
If it did not open the documentation?
Yeah, because it doesn't, it says you don't have permission to view this.
On your own computer?
No, lab machine.
Oh, interesting. Can you drop me a note to remind me of that the documentation is not opening? We will ask if they can fix that. If the book icon's not working, honestly, just Google. So like I would scroll up to the top here, UI window class reference, and then quite literally, frankly, Google is a little better than apple.com for finding stuff. There it is. So you see the exact same thing this time in a browser. But we'll see if the lab can help us fix that. All right, so that was a quick digression just to where to find the documentation. But the last line of code here now is self.window make key invisible. By make key, we mean make it the key window, the thing that's listening for key presses and whatnot. Visible means make it visible. Return yes to signify yes, the application has launched. So that is the only method that we should turn our attention to initially when we want to start writing code. But there's no mention of UI here. We haven't actually touched this file, and indeed, we don't often have to even edit the app delegate, because what's in the rest of this file is really just stubs for some other methods, optional methods, in the UI application delegate protocol. And there's nice verbose comments here telling me what they do, but these are the low-level opportunities I mentioned before. If you care about when the application will resign active status, that is right when it's about to be backgrounded because you hit a button or a phone call came in, did enter background after that actually just happened. Will enter foreground, did become active. So these are low-level opportunities you have to sort of clean up the state of your world, save state so that the game isn't interrupted. And I can say from personal experience, there are some infuriating games in the App Store whereby if you get a call or you manually hit the home button, you lose all of the progress you just made in that game because someone didn't think to implement these methods. It's that simple. You know who you are out there. Yeah. Automatically. It's just part of the template. It's not so much generated as it is written by a human who then saved it as a template and then shipped it with Xcode.
Okay, so but when we're starting a new app, it's proper place to start with a template like this then?
Yes, I would. For the staff's choice of assignments, you will be required to start with the utility application. And even early on, I think you'll find it quite valuable to start at least with the single view application because you can even reconstruct the other templates very easily from that one. And just to be kind of neat and tidy, this is all just comments. I'm going to go ahead and just clean this up and really simplify the app delegate. I'm going to get rid of this comment here because it's not doing anything for us. And this is the only code now that's driving that part of the application. So it's apparently, though, initializing a view controller with that nib. So let's take a look at that file now as well. Here's its header file, which is generally a good place to start when trying to wrap your mind around some new code base, just because, if nothing else, because there's less stuff in it usually. Here we have a very uninteresting class declaration of a class called view controller, and it descends from a parent class called UI view controller. What's the advantage of view controller? The advantage of this is that it's going to give us, thanks to inheritance, some very basic useful functionality, like how to respond to rotations of the screen and some of that low-level stuff that just wouldn't be interesting to implement again and again and again. So let's see the M file now that implements this. And notice here I can clean this up. You do need to have this in there, but that's now the class declaration. In the M file, It's mostly just some stubs here too. So at the top, I'm importing the header file. This we'll come back to. This is what's called a class extension. This is currently in vogue, especially in Objective-C 2.0 and Xcode 4.3. It's a place where you can put private methods, essentially, and private properties, even though those methods can still be called by third parties, by other objects. They're just not advertised as such. So the compiler will either yell at that person, but Objective-C doesn't have the same visibility protections as languages like Java does, which is why some people have been able to take advantage of, say, undocumented features of iOS by passing messages whose names they've figured out, even though they're not publicly advertised by iOS, like the tethering features and stuff like this. That's in there, but it's not documented, at least publicly. So now there's these three methods, and these are not all of the methods that compose a UI view controller object necessarily, but there's some commonly used ones. So viewDidLoad does what the name says. Once the GUI has been constructed, generally from a nib file, this method will be called in case you now want to make some refinements. What kind of refinements? Well, earlier I just dragged a label into my UI and it just said label. But what if I actually want to programmatically change what that label is? I can do it here, for instance, and we'll see how to do that in a moment. Super viewDidLoad, though. Again, the common paradigm here with inheritance and with the SDK is if you're going to override any parent class's methods, you better call the parent class's similarly named method, unless it's your own class hierarchy where you have the discretion not to do that. So do take care to do that. ViewDidUnload is the opposite, when a whole bunch of UI stuff is evicted from RAM, possibly because the app was backgrounded, possibly because the user flipped the interface around to look at some settings, possibly because they hit a menu option and everything slid to the right. Anytime something is off screen in iOS, it is vulnerable to being removed from RAM for performance reasons. You can prevent that, but generally you shouldn't have to, because in the whole MVC paradigm, where should your data really be long term? In the model, right? It shouldn't be being stored with any kind of expectations in the view. You should be able to reconstruct it, if with a bit of effort, from the model through the controller to the view. And you can, again, simulate often the eviction from RAM with that little toggle in the simulator, which is a quite helpful diagnostic trick. And now this very lovely named method, should auto-rotate to interface orientation, takes in as an argument a value that represents what the current interface is. Is it this? Is it this? This? Or the other way? And then you get to return true or false, sorry, yes or no. That is a supported configuration. So in English, what does this expression here mean? What orientations will this particular app support by default?
Everything other than upside down.
Everything except upside down, where Apple upside down means the button's on the bottom normally. This is upside down, which means if you turn the app this way, it's going to stay stuck in this mode or this one, whatever came just prior to it. This is purely up to you, but convention generally says don't let the user put the button on the top for whatever reason. All right, so let's actually start doing something with this now. So let me go ahead and start from scratch here. I'm going to start with the single view template. I'm going to call this nib1 to be version 1 of this. Hit enter with all the defaults from before, and I'm back to a clean slate. So if I go to my nib file, I now have just this clean slate here. And I'm going to go ahead and do one thing. Just for practice, I'm going to click on the view. I'm going to change the background to be, just for kicks, let's say carnation. All right, this will look nice and tacky on the overhead here. All right. Now I'm going to drag, let's say, a text field so I can accept some user input. I'm going to use the little guides to drag this open there. I'm going to click on it once and then give it a placeholder text name, because that's where I want the user to type in their name. So that's the UI we're constructing now. And then I want to have a rounded button here, and we'll just say go. And the goal of this application, quite simply, is when I type in a name and click go, I want a little alert window to open up and say, hello, David, or hello, so-and-so. That's going to require, though, writing some code. I can push the button all day long, but it didn't do anything before, and it's still not going to do anything now. I can type into the text box, but no one's going to know that I actually did until I somehow wire this interface to the code in those files there. And this is where Interface Builder makes things a little nice and easy, but I have to have some foresight here. So I'm going to go into my view controller here, and inside of my class declaration, I'm going to go ahead and say I want a property, and I'll come back to the parentheses in a moment. I'm going to say that I need a pointer to a UI text field. Xcode has really nice autocomplete, as you learn. Star text field. So I want a pointer to a text field so that in my code, I have some way of expressing programmatically that object in the nib. Now, I need to specify a few things in parentheses here. I don't care about multi-threading. I do want this to be read-write. And then in terms of the other feature for now, let's just take this for granted today. It's a weak pointer for reasons we'll get into probably next week. But for now, anytime you're declaring a pointer that's going to point to something that's actually implemented in a nib, a weak pointer suffices instead of strong. So I do need to do one other thing, but I'm going to intentionally forget to do it for now so that we can do one other here. Property, non-atomic, read-write, weak also, UI button, and I'll call this star button. I'll keep things alphabetized here. All right, so now I have two properties declared. How do I create my getters and setters? OK, so I have to go into my M file. And don't be misled by this interface. For now, I'm going to actually delete this for now, just to hide that detail from us. It's called a class extension. And I'm going to synthesize the thing called text field. And I'm going to back it with an instance variable called, just by convention, text field. And then I'm going to synthesize the button and back it with the ivar called button. So now I have my getter and setter. And I have what other feature? Dot notation. All right. But the first is the more compelling of the two, frankly. All right. So now I want to go into my nib, and I want to somehow tell Xcode that that pointer should point to that object, and the button pointer should point to the button object. So it'd be nice if I could literally drag and drop, and you actually kind of can. I'm going to do it in one of several ways here. I'm going to hold down Control, and I'm going to click on Files Owner. Now, this is a very common paradigm in iOS. The owner of something is some other object. So in this case, this is viewcontroller.nib. Take a guess. Who's the owner of this nib? View controller. Really, viewcontroller.m, you can think of it as. Now, why is that? Well, recall that in the app delegate, what did I initialize the view controller with? With this nib. Right? So I did view controller init with nib named, and then view controller.xib effectively. So the owner of this nib is the source code file, viewcontroller.m. So if I control click on here, I should be able to somehow connect that file, represented graphically by the cube, to the user interface. But unfortunately, there's nothing I can drag and drop here. And we'll explain what some of these other things are. But what I'm looking for is not here at the moment. I want to see in this drop-down menu button and text field, the 2 pointers that I declared. To do that, I need to actually leverage a clever little Xcode trick in my H file here, whereby I need to provide a hint to the compiler that this button should actually be considered an IB outlet, interface builder outlet, and this guy too. This is a hint that's actually declared literally elsewhere as define IB outlet. That's it, or think of it as quote unquote. It is type def or defined to be quote unquote nothing. So in other words, it has no effect on compilation. But Xcode, being an IDE, will now use that and realize that when I control click on Files Owner now, notice what it knows exists. I now see those 2 pointers in this little drop-down menu, which means I can now connect them by dragging from here over to the button. And as this line suggests, this means that when I run this program, the address of this button will be stored where? In that pointer. So it's as though I'm plugging the UI into the code or vice versa, however you prefer to think about it. So this line will disappear in a moment, but it's going to do that linkage for me. And as soon as I do, notice that I just see a little reminder. The button outlet, i.e. pointer, is connected to this thing called Go. That's in my code. Now, if I get rid of this, you actually don't need to pull up that little menu. I can actually just control click and start dragging. If you prefer, let go, and then I'll see on this side of the world the same types of options, but because I let go on the button, I'll only be showed things that are applicable here. One is view, which you get for free thanks to some class hierarchy, but button is the one I defined, so I can click here and say map that to the button. Similarly, if I go from Files Owner to Text Field and then let go, I can choose the text field. And if you really want to get fancy, it's not going to fit very well on this screen here, but let me shrink this. Oh, as an aside, and I mentioned this in the spec, Xcode, I believe, ships with these things by default, and you somehow have to know what the cubes represent. If you click the arrow, you'll see the view that I've been playing with, just FYI. Let me go ahead and pull up this little butler icon in the top right-hand corner. This lets me see 2 different files at once, and generally what it will do is make a a best guess as to what two files you, the human, would probably like to see side by side, but you can override this via the little breadcrumbs at the top of each of these halves of the window. And now notice what Xcode has done. Because I said IB outlet, it gives me this super user-friendly circle, so I can now literally wire my code to the interface by dragging and dropping here. So you have like half a dozen ways of actually combining your UI to your code. But the irony is, if you're like me, you will sometimes forget to do it anyway. So when you click a button and run and nothing happens, there's no response, it's probably because you forgot the linkage. And because, per last week, you can pass messages to nil without things crashing, you're just going to be ignored. Those are the symptoms you're going to typically see. Just nothing's going to happen. It's not going to crash, but you forgot to do that wiring. All right, so now we have the wiring all together, which means that now in my code, in my viewcontroller.m file, let me turn off the butler, I can actually now, in any of these methods, I can actually talk to those UI mechanisms. I can change the placeholder text. I can read the value from the text field. I can change the text on the button. I can change the color on the button. In short, I can do anything I want. Interface Builder is really just simplifying the process of getting things started. Yeah? The linkage will be represented in, I think, the nib file itself, or in some Xcode specific metadata. No, it's not going to generate code for you. It's not. It will. I suspect it's stored in the nib file. I'll have to poke around myself. But no, it's not going to create code that you yourself will see or could accidentally delete or change. It's going to do it underneath the hood. And this is one of these details of Xcode that on the one hand is great because it makes it super easy, at least initially, to start creating apps. But at the same time, it hides a lot of details so that when you just run and compile your program, there's stuff magically being instantiated and wired together. Indeed, when you look at the nib file here, this is a pictorial representation of an object called a UI button. This is a pictorial representation of a UI text field button, object rather. So really, alternatively, I could be doing something like this in code. And we'll see an example before long where you will actually do something like UI button, star button, gets, UI button, alloc, and then you'll call its init method, and so forth. You can do this all manually, but the nib file is just kind of hiding those details, at least for things that are just easier to do with a WYSIWYG editor than with code sometimes.
So I guess your variable name should be pretty good, right? Because
yes.
they can map to different fields.
Yeah, and your verboseness, you'll be in good company verboseness-wise. So being specific, if you had two buttons, like calling it button left, button right, or button middle, something like that that's expressive, don't get into the habit, as I used to be in, of like B or just generic button. A little more precision will go a long way. Yeah?
When you actually create a button programmatically, you don't have to specify to the UI to actually use that button.
Correct. So after this, we'll do an example without the nib. We will just delete the nib file and do it old school.
Yeah, if you did it that way, you wouldn't have to connect it to the UI.
Correct. So this dragging and dropping is purely meant to make Interface Builder talk to actual code. You do not need an Interface Builder at all. It just makes things easy, at least initially. Yeah.
Is there examples where you would not use Interface Builder? It wouldn't work out for you? It would be better to code it? Is there...
Good question. When might you not use the Interface Builder? Some of it's religious. Like I have friends who just hate it because they hate it, and so they would write code instead. Perhaps when interfaces get all the more complex, it just can become a little tedious. If you want to have 20 different UI elements, it might just be easier to instantiate them in a loop, for instance, especially for a game, if like asteroids with things moving around or the like. And also, you'll see in section tonight or next week in lecture, Xcode also introduced the notion of storyboards, whereby you can actually map out your whole application in terms of a flow. And I'll just paint a little quick picture here that is essentially the embodiment of multiple nib files. But if you know your app can kind of be storyboarded like a TV show or a comic strip, you can actually use the same notion of dragging and dropping to say that this screen should lead to this one should lead to this one, or maybe that one, and so forth, which just gives all the more expressive capabilities to the GUI. But here too, not at all required, is not going to do anything you couldn't do already in code. So it's really personal preference. Initially, certainly for the first staff's choice, I would strongly recommend Interface Builder because the spec has been, the project has been chosen because it lends itself not only to a utility app, but also to the dragging and dropping of fairly simple UI mechanisms so that your focus intellectually can be on the code and not so much on the GUI. Was there one more question? OK. All right, so I now have this interface. I need to somehow be able to talk to it and respond to the button press. So I need to do one other thing here. I'm going to go ahead into my H file, and I'm going to say, you know what? This class is going to have a void method called go that takes what I'm going to generically call a pointer to an ID object. So this is a very common paradigm here, whereby when you want UI mechanisms like buttons and text fields and the like to be able to send messages to your actual code, the convention you would adopt is implementing things called IB actions. And an interface builder action is actually just another little compiler trick whereby you actually don't say void, you say IB action, even though IB action is just void underneath the hood. So it has no effect on the actual code that's generated. But what this now means is I can go back into the interface builder, and I can drag from the button to file's owner and say when this button is touched, what method should you call? This one here. So if you think back to web programming and jQuery and registering event handlers for on-click and on-blur and on-focus, same idea here where there's a whole bunch of events associated with a button. When you touch down, when you touch up, when you touch outside of it, when you touch inside of it, all of which you can listen for and invoke event handlers as a result. So an IB action is effectively an event handler, specifically for something that you did with Interface Builder. So I can now go back to my nib file. I can hold Control and this time go the other direction, whereby the button is going to be dragged and dropped over to file's owner. And now notice, which of the events do I want to send? I can now choose Go. And now, if I go back and hover over the button, you'll see all of the possible events that interacting with it somehow might generate. But the one that's relevant here was chosen automatically for me just by statistical likelihood, touch up inside. So that means when I touch up, but inside of the button, let go of the button, go ahead and pass the go message to whom? The file's owner. Who's the file's owner? View controller. So that means we're almost home here now. I can now go into the file's owner, namely the viewcontroller.m file. I'm going to scroll down, and you know what? I'm actually not going to bother touching the UI any further, so I'm going to get rid of that skeletal code. It's just not necessary. I'm going to go ahead here and say IB action. And notice here, per the jargon earlier, selector is really the precise terminology for a method. So I'm going to go ahead and call it go. I'm going to go ahead and then leave ID and sender alone for now. And this is the method that's going to get called when that button is touched. So let's do a quick sanity check. NSLog, I'm going to say here. So when I go ahead and run and compile this code, we should see the interface that I expect out in Interface Builder. And I'm going to go ahead and click Go. But notice, let me open the debugging window in the background. Bottom right, if I click Go, interesting. So I've now started to wire together the interface with my code. Of course, it'd be nice to actually do something here. If I type in my name here, it's going to completely ignore me. And notice, these are some of the things you get for free. By using a UI text field, simply clicking and giving focus to the name field is going to pull up that keyboard automatically for me. So let me go back to my Go implementation. And let me do a couple of things. Let me go ahead and first, let me hide the keyboard. So I can pass a message to my to self's text field property called resign first responder status. So I mentioned the word responder earlier. What's this going to do? Well, these various UI mechanisms can respond to events, human interactions. And by default, the text field's response is to respond to the event and throw up its keyboard. If, though, I call the go method now, it's going to resign first responder status. So it's just going to say, OK, I'm done. And its behavior when done is to dismiss the keyboard. So I'd actually like to do something a little more interesting than that. So I'm actually going to do this. First, I'm going to construct a string here, ns_string s, or rather a pointer there too. I'm going to go ahead and say ns string with format, and you can see all of the various, per the richness of the foundation classes. String with format. I want a string that says hello, comma, someone. So I'm going to do a placeholder there. This method, much like nslog, takes a second argument, which in this case is going to be self.textField, but I need a string. So per the documentation, it turns out that if you want the actual value inside of the text field, you need the text property. In HTML, think of this as the input elements .value property inside of it. So now, what have I done with this line of code? On the right-hand side, I've declared a pointer of type NSString, a pointer to an object of type NSString. On the right-hand side, I've allocated a string and initialized it to hello, comma, so-and-so. Now, I say allocated, but this is actually what kind of method? It's a class method, otherwise known as a convenience method, which means it's doing the allocking and the initialization for me. It's just a little cleaner and more succinct than alloc and init again and again. Okay, so now I have this string. I'm getting a yellow warning because I haven't done anything with it. So let's go ahead and create a little pop-up. UI alert view. We'll call it the pointer alert. I'm going to go ahead then and allocate a UI alert view object with alloc. And then I'm going to initialize it with this crazy long method name. So here we go. This method is called init with title, message, delegate, cancel button title, other buttons, titles. All right, this is going to be a little bit of a mess at first. So the title is just going to be quote unquote hello. But notice the @ sign is important there because it's an NS string, not a char star. The message is going to be S. So the delegate for now is going to be nil. I don't need a delegate, but we'll come back to that. Cancel button title, this is going to be thanks. And then the other button titles, I don't want any of these either. So let me close the square brackets, semicolon. And now this is a mess to read. So if you start hitting enter after each of the arguments, you'll find that Xcode will line things up on the colons for us, which is kind of nice. Makes it a little more readable, certainly. So now we have a full message pass. It's yelling at me in yellow. Why? I got to use it somehow. So now I'm going to go ahead and say alert show. Whew. Now we have, hopefully, if I did this right, a working program. So let's take a look. I go ahead and run it. And now I'm going to go ahead and click the text field, David, go. Voila. There we go. Hello, David. Everything's nice in there. I click thanks. And now I can play this silly little game again. Hello, JP, go. Unfortunately, I'm not the best at error checking, so a little bit buggy. But we could fix that with some if conditions and the like. But for now, the takeaway is how we've wired this thing together and the event messages that are being passed back and forth. Any questions thus far? Yeah?
I feel like the synthesis, the order of are those parameters? It didn't seem like you followed the same order. Oh, I'm sorry, in the other, the at property.
This one here?
That's the one, yeah, at property. The order of those parameters, or whatever they're called, I feel like they were different.
Oh, I'm a little OCD. I alphabetize them.
Okay,
So when the words change, the order change. No, order does not matter. No, this is just me being anal. No other normal person does this. No, I've had arguments with friends over this.
So if you have a lot of them, you rearrange them all the time?
Well, I mean, not all the time. No, I cluster them by functionality typically. But within the parentheses, which I think you're referring to, even those this is really becoming a referendum on me, though. Yes, I tend to alphabetize everything. All right, a little dark secret. Okay. Other questions, not about me. All right, so let's clean this up a little bit. And for time's sake, let me open up a prefabbed example here, nib2. It is already on the website, and there's a PDF too if you want to follow along there. But just to reveal a couple tweaks we could make to this, let me go into nib2 and show what's different here. So I'm going to go ahead and run and compile this. And let's see if a sharp eye can distinguish what I've cleaned up a little bit here, besides changing the pink to white. So now I'm going to type in David, click go. OK, and now what changed? Yeah, it auto clears the box. So what's interesting, though, is notice when it auto clears the box. I click go, still there, thanks. So this allows us to introduce the general design pattern in iOS of delegation. So the show message that we passed to the alert view a moment ago is an asynchronous call. It's a non-blocking call. That message will be passed, and that method call effectively will return immediately. This is advantageous because you don't want the entire phone to grind to a halt just because the user has not hit an OK button, right? This would be very 1980s, 1990s style of programming before we had multi-threaded environments where printing something would occupy the computer's entire attention, for instance. But iOS is very much multi-threaded, and so even though you might have this modal alert view in front of you that you have to interact with, you can still get calls in the background, notifications can come in, mail can be received. You can't interact with the rest of the app, but you don't want this thing to grind everything to a halt, especially if your own app maybe is an email program. You still want the inbox to keep getting messages even if I can't interact with them until I dismiss it. So that is to say that the alert view's dismissal is not tied to the return of that show method. It happens some number of seconds, maybe minutes later if the user walks away from the device altogether. So I need some signaling mechanism so that when the user does later touch the OK button, or the thanks button in this case, I am sent a message, I being the view controller, that the user dismissed this message. At which point, what do I apparently want to do in version 2 here? Clear the text box. So simple idea, but representative of a very common paradigm now. So notice a couple of differences that a couple changes that I've made here. First, in my header file for viewcontroller.h, and my changes are isolated to these two files here, notice an addition. And actually, I should take back. Before in version 1, we did have an outlet for the button, but it turns out I didn't need it for the code because I never talked to the button. I listened for the button in this direction, but I didn't need to talk to the button in this direction. So in version 2, the one I did last night, this is cleaned up. I didn't bother having an IB outlet for that guy. But what else is different besides buttons omission here?
Protocol for UI alert.
Yeah. So this class now, view controller, besides descending from UI view controller, it's implementing the UI alert view delegate protocol. Now, I don't know what that is, so let me option hover over it. Little quick documentation. Let me pull up the real documentation and scroll down. And what you'll see here under tasks are these are all of the methods that I could or maybe even need to implement in order to implement this protocol. But it turns out only one of them do I need to care about here. Alert view did dismiss with button index. This is the message that can be sent to me if I register myself as a listener for that event. So how do I do this? The first way I do this is in my source code, I specify that this view controller of mine is going to commit to that protocol there, UI alert view delegate. Now in my M file, I need to take that to heart and somehow implement one or more of those methods, and I have done just that. I copied and pasted from the documentation the method signature, void, alert view did dismiss with buttons, and so forth. And all I want to do in there is clear the text field. So how can I clear a text field? I thankfully have an IB outlet to the text field already, so I do self.textfield.text equals nil. And that has the effect of zeroing it out, and I just see the placeholder text again. But the point is that functionally, this is very different from having put this here. If I had put that code here, what would the user see instead in this version? What behavior? Cleave it. Exactly. The moment it pops up, the text field gets cleared, which frankly maybe is very reasonable and compelling, but I didn't want to do that. I wanted it to happen only once you clicked thanks. So there's one other key difference here that maybe is jumping out at someone. In order to teach the alert view object that I am the object to whom you should send this message, what change have I made to the code that's on the screen here?
Reference self for the delegate argument.
Exactly. So whereas previously I very quickly said, all right, delegate is just going to be nil. Now delegate is going to be self. And so this delegate design pattern in iOS is, again, very common, whereby you create an object. You want to teach that object who you are. So you give him a pointer to yourself so that he can later, at some point in time, send messages back to you. The alternative, if you wanted to listen for the closing of that alert view, would be this would have to be a blocking call. And no other code could execute until this method returns. And that's just not consistent with the idea of a very dynamic, very responsive, low latency user interface.
The delegate itself isn't self the button, it's the parent of that.
Parent. No, the parent of that is technically a view. Self in this case refers to the class we're currently implementing, which in this case is the view controller class. And that makes sense because the event handler, this thing up top now, is inside of that class. Any questions? Yeah.
So the thing that top an alert view where you make the box clear, is that called just because you are running the UI alert view command? Is that what calls? Because I don't see it getting called anywhere in here.
So it's not, because someone else wrote the code that's calling it. So it's these two lines here that induce this behavior. So because when I instantiated and initialized this alert view object, this UI alert view object, which is a class Apple wrote, because I passed in this third argument, which is a pointer to a delegate, so to speak, this is informing the alert view object who should you pass messages to when interesting state changes happen. For instance, the user touches a button. So this is the key line here.
Okay. Now, would it still have worked if you didn't put the protocol line in the H file?
Good question. So Xcode is actually get this thing here. So Xcode is getting more generous, and frankly, yes, it would. But in the interests of actually writing code that is then both self-documenting, but also so that other people can import it and know what you implement, best practice would suggest to put it in the header file, as I did the first time. So good practice works, but bad practice. Yeah?
You said this is a non-blocking call, asynchronous call. Now, how do we know that this is an asynchronous call? Is there something that tells us? And number two, does it affect the, is it like the path of execution? Can the line which we write after it can be executed before that or not?
So in answer to the first question, you know it from the documentation, or just from the test we're about to do here. So hello there 1, hello there 2. It is going to be non-blocking. So what it's really doing underneath the hood, even though this part I don't think is clearly documented, is when you call alert show, what there actually is underneath the hood is there is a stack of messages, alert views that will be displayed to the user. So what this is doing is it's pushing this object onto a stack underneath the hood, or actually probably a queue, so that if frankly there's a lot of a lot of alerts that pop up, the user will see one, then when they dismiss it, the next one, then the next one, then the next one. So this function is not doing all that much. Show is not actually showing it, it's adding it to a queue. And mail, if those of you with iPhones, this too is infuriating, they've never gotten the mail application right, whereby if you lose network connectivity, like in the subway, you'll often get like 3 alert views saying can't talk to Gmail, can't talk to Gmail, because they're just pushing things onto the stack in this way, or rather queue in this way. So just to prove it here, I can run this code here, and I should see hello there 1 and 2 instantly before I even dismiss the view. So if I click go, there they both are. I've not yet dismissed the button, and now it's dismissed. So they're happening immediately before I even have time to interact with the button. So just to show independence on interface builder, let's open up this example here, nonib.xcode project. So this one does not use a nib. In fact, the first thing I did when writing this application is I started with single view template, then I deleted the nib file, and then I started manually constructing the same exact user interface that we've been playing with thus far, minus the pink. So if I compile this version, no nib, and this source code 2 is online, notice that you get the same UI. Actually, this time I chose black, but the implementation now is entirely in code. So let's see how we did this here. So let me go into the code base. Let's start with main.m, looks normal. AppDelegate.h looks normal, and by normal I mean no difference yet. AppDelegateM, no difference yet. This too is all the same. So the changes must be isolated to my view controller. So I have a couple of things here. And actually this even wasn't strictly necessary. Here I explicitly declared that I do implement this particular method, but this is really for self-documenting purposes. Which one I implement, it's not strictly necessary, which is to say there's nothing new in this one either. And actually this I should fix. This can be weak per my comment earlier. But here's where the actual material changes. So notice that we have some familiar methods in my .m file. I have the auto-rotate interface. This time I'm arbitrarily just supporting portrait mode. Here I have alert view did dismiss with button index. So that's just responding to the users clicking thanks. As an aside, this argument, there are two arguments passed to this method, both of which we've ignored thus far. The first is a pointer to the alert view object in case you care to have access to it. The second is a number that's probably 0 or 1 or 2. Even though I just had one thanks button whose index would be 0 by default, you can have multiple buttons on an alert view. So that's how you distinguish which one was touched. Go is the same as before. I resign the first responder status. I show an alert. Scrolling down, that's it there. This feels a little new, and you'll see this in the templates. Know what this does? It's a little fluffy, but useful. It's just a preprocessor directive that Xcode uses to build this little cheat sheet of options in the drop-down menu so that you can jump around within your own file to the individual methods and have bold-faced section headings atop them. So it just helps you cluster related methods together. It's just an aesthetic thing. It doesn't functionally change the code itself. All right, so I must have scrolled way past the interesting part. So indeed, there's this method here, load view. So we've not implemented this method before. We have seen methods called viewDidLoad and viewDidUnload, but at that point, it's too late. ViewDidLoad is called when my view has already been loaded. And by view, I mean the aesthetics of the app. Now, in all previous examples, the aesthetics of the app were embodied in what file? The nib, right? So viewDidLoad is called as soon as the nib is deserialized as XML, loaded into memory, all the objects are instantiated, all those blue lines are connected with pointers, but there is no nib now. So now I actually have to implement a different method in the UIViewController parent class that's declared there called loadView. It takes no arguments, it returns void, but its purpose in life is to create manually the view if you have no nib. So what's interesting here is that I have to do everything from scratch. This is why, frankly, Interface Builder is compelling sometimes. So first, I have to create a default UI view to fill the window. And I'm going to do this trick with initializing it with the whole screen's application frame. This means give me the whole rectangle. And the important detail here for load view is that per the documentation, it must set self.view before returning. So at this point, I just have a gray or black or white, whatever the default is, rectangle on the screen. So I'm back at now the nib starting point, effectively. But now I have to add those subviews. I have to do the equivalent programmatically of dragging and dropping buttons and text fields. So I did a little more work than I strictly need to, changing a lot of aesthetic details and functional details. So what am I doing first? I'm creating a CG-rect, which is a rectangle called frame, calling this C function. And this frame is going to be offset 20 pixels from the top and 20 pixels from the left. It's going to be 280 pixels wide and 31 pixels tall. Why? Because I just looked at Interface Builder. I created one by default, and then I looked at what the default measurements are, and I said, fine, I'm going to manually just do it here, whatever Apple decided to do. But this is arbitrary. Could be most anything. Then I call self.textField, and this is a property that we had before, but rather than rely on Xcode to wire up this pointer property, I have to do it myself, so I'm going to allocate a UI text field objects. I'm going to initialize it with this rectangle that I just created, so it knows where to exist. Then I'm going to set a bunch of fluffy little configuration details. Do you want to auto-capitalize, auto-correct, what border style? Things that you could otherwise do in the GUI from the right-hand side of Xcode. And this took, frankly, a few moments to actually look up what all of the property names are that correspond to the WYSIWYG editor, but you get to know the documentation that way. Then down here, now it gets interesting. I now need to mimic in code the idea of those blue lines, the outlets that I wired up before, and the actions, rather. So I have to call self.textField to give me a pointer to this text field object. I'm going to add as a target, so to speak, myself being the view controller. So this is delegation model again. Action selector go. So this is a function pointer, effectively, familiar. So go is the name of the selector, but I can't just say action : go : syntactically, if nothing else, it would confuse the compiler. But this symbol, @selector, and then in parentheses the name of a method, means call this method, or rather pass this message, go, to this object, self, what happens? Well, for what control events? The UI control event editing did end on exit. In other words, when the user dismisses the keyboard, you should call that method here, go. So this is the reason here, and we didn't see it when I was using the mouse. I want to be able to respond to the mouse button going down on the go button or the user hitting enter. So I have to listen for two different things. This is my way, and I think I did it in the prefabbed version. This is my way of listening for the enter key. The event happens to be called UI control event editing did end on exit, and this is a constant declared in UIKit. Finally, how do I actually do the equivalent of dragging and dropping this newly created UI text field object onto the screen? I do self.view, add as a subview, self.textfield. And because of the frame, it knows where to put itself on the big rectangular screen. Then I do the same damn process for the button. And even this is a little more precise because I figured out where I want the button to be. So this isn't to poo-poo the idea of doing all this in code, especially for larger, more complex interfaces. It's probably more compelling to do it this way if you can automatically do things in loops and so forth. But this is what Interface Builder simplifies for us. And the other event that would be worth pointing out here is that touch up inside equivalent using code. So that go is also called when the user clicks the button physically. Yeah? Absolutely, you can do a mix. If you do a mix, though, you would not implement the load view. That should be either or with the nib. Rather, you would override view did load if you want to do things right after the fact, or view will appear is another one once it's loaded but hasn't yet been shown to the user. That's your opportunity to do some more fine-grained control, and that's very common too. Yeah.
With the builder, you dragged out the button and the text field and all that. If you then put that on like an iPad, would it keep it relative, or does it use the actual pixels? Because here you're giving it, absolute numbers.
Good question. So we'll talk about this in the weeks to come, but in short, no. If you have an iPad, it's not going to be the same dimensions. So what you would typically do is have separate views. So you would actually implement a different code here, and you would with like a switch or an if condition check what the frame size actually is. Or in the world of Interface Builder, you would have two separate nib files, one for iPad, one for iPhone, and the compiler, or rather the OS, figures out which view it should actually use. Or you can at least dynamically do things so that irrespective of the size, you can use things called springs and struts, which is just a GUI feature where you can say that this text field should actually grow to fill the screen. And just so that we've seen where that is in an example that has a nib, just so you can play with that feature, which is quite useful for rotating the device, where you want the thing to stay in the middle of the device, irrespective of its dimensions. If I go up here, open up the inspector on the right-hand side with the ruler, you can click on these things, and you'll see a little simulation of what's going to happen to the widget when you play with these various struts and springs. So just a teaser then. Again, this is not something you have to dive into just yet. It's officially released next week, but we put it out there in case you'd like to dive in early. The project that's currently officially out is the one involving just getting Xcode set up, writing a couple little Hello World applications. But Evil Hangman is going to be the staff's choice of iOS projects. And in this project, we will hand you a dictionary file containing 214,000, 140,000, a lot of English words in the form of a property list, a big XML file. And you have to implement not Hangman, which frankly is a bit boring after a certain age, but Evil Hangman. And in Evil Hangman, the computer cheats, whereby when you begin guessing letters that are in the chosen word, well, the computer starts to change its mind. If I guess E, the computer is then going to say, no, this four-letter word has no E's. And it will whittle down the 140,000 words to only those words that don't have E's. Then you guess A. It's going to narrow the list down further so that it can again say, nope, no A's. And you'll then say I, O, U, and so forth. And eventually you'll corner it, and it has to commit to one of those letters being in it. But what's great fun, especially to play on friends or colleagues or family members, is that they really feel awful at Hangman, because if you don't tell them that it's Evil Hangman and you just call the game Hangman, they just think they're really bad at guessing letters. Because invariably it will be a super simple word like puppy that's the answer. That, oh my God, I should have thought of that. But no, because the computer was trying to evade your guesses. Just to give you a sense of this, I thought we'd conclude with a very quick demo here of one such implementation. You do not need to make yours look quite like mine. You'll see in the spec that you're allowed quite a bit of design discretion. But just for fun here, we have a four-letter word. I've preloaded it with a dictionary. In white, you see all of the letters of the alphabet. So why don't we conclude by playing a bit of Evil Hangman here? Would someone like to guess a letter? No. T. No. I. No. E. No. S. No. O. It was duck. You're all very bad at hangman. But that's, again, because the program is evading constantly your guesses as much as possible. So you'll see that as part of this game, you'll need to have a settings button, which will flip the interface around so that you can choose the word length and the number of guesses the user actually gets. So it'll be an opportunity to wire things up in Interface Builder, but then actually write code that interacts with this. And then you'll see there's some really interesting computer science questions or data structures questions that you'll need to answer as to how to implement this evasion strategy and take a fairly large corpus of words and keep narrowing it down and trying to figure out what subset of words to actually use. So that will be Evil Hangman. Tommy will walk us through the spec next Wednesday, a couple days after lecture. Tonight, JP has section now. I'll stick around in the lobby with questions, but otherwise, we'll see you next week. All right, so we are back. This is lecture 8 and iOS continued. So quick warm-up to get us back in the swing of things from last week. What did we do last week?
Crash course on Objective-C.
OK, crash course in Objective-C. So quite fast, and realize, especially for those of you for whom C is new or rusty, realize some of those same topics will recur, and by all means ask questions, especially about pointers and memory management, objects and the like. But today we'll actually start looking at iOS programming, not just Objective-C. And Objective-C, recall, is a layer on top of C. So it gives us object-oriented features on top of this older language. To motivate tonight, I thought I'd put up this screenshot of an app that one of our own 76 students last year had worked on since last year for their company, and it just debuted literally this weekend in the App Store for 99 cents. So this is an app with which you can get nutritional information about various foods that you can drag and drop into this wok, create a little bit of a stir fry, click over, and actually see nutritional information about that. So if you're looking to see what an E76 student did just a few months after completing the course last year, realize this is now for sale in the App Store, just 99 cents. So that was among the first downloaders, I think, this past weekend, called Drag and Cook. All right. It's, well, you know, so it could be. They did send me a redemption code. I wasn't sure how to use it. And it was just easier to pay the 99 cents than Google around to figure out how I could redeem it for free. So, and I'm teaching the course. So what does that say? But I'll look into that if I can. All right. So. OK, so yes, this now obligates you to send me redemption codes, because clearly I won't redeem them if you put your own apps in the store after the class. So this is what we looked at last week. So this was Hello World, written in this language called Objective-C. And let's just tease apart some of the pieces of syntax and functionality, even with this trivial little program, so that we can then use it as a stepping stone to much more interesting ones. So up top here, we had sharp import, which in contrast to sharp include, does what for us? Yeah.
It would include those, except it won't duplicate imports.
Perfect. So this effectively does an include, which is to say a copy paste of foundation.h, puts it right there atop the file. But import, unlike include from yesteryear, ensures that that's only going to be done once. And the motivation for that is that if you have constants declared in this .h file, enums, or any kind of global declarations, it would be a compilation error if you redefine that same thing identically elsewhere. So then we have int, main, argc, const, char, star, argv. These we will never need to touch in an iOS application, but we do still need the framework for a main application, because as soon as main gets invoked, it pretty much was going to hand off control in the world of iOS to another function altogether that is only going to return when the application itself terminates. But main will look effectively like this, just a little more interesting, namely this here. So it's wider, how you write an iOS app, but what main does is it simply invokes a function called UI application main, passing in some of those same arguments. But more interestingly, its fourth argument is this syntax here. So we have a function call, C-style, ns-string from class. Then we're passing in the return value of a message called class being passed to app delegate, capital A, capital D. And as we'll soon see, app delegate is a special class that comes with any iOS application to whom control of an application is pretty much immediately delegated. So we're going to see a layering today whereby main gets invoked as it has been for some time. It passes off control to UI application main. It in turn is going to pass control off to a class called app delegate. It in turn is going to further pass control. And so as you dive into this coding yourself and as we explore tonight's examples, just remember that there's going to be a whole bunch of new function names, method names, and class names, but it's really the process that's going to be one of the most important takeaways, so that when you sit down with a clean slate or with some existing sample code, you can start to navigate it on your own. So I'll try to offer some of those tours verbally tonight. So here's how an iOS application works. So this screenshot here is from essentially one of Apple's how-to documents. And we begin our story up here at the top left, whereby a user taps the icon on the screen, and that results in the program running. More concretely, that means that main gets invoked. Main in turn invokes UI application main. The UI application main in turn loads main UI file. Whatever that is, we'll see what that means in just a moment. But that brings on screen whatever is visually interesting about the display. Then in turn, after the UI is loaded, the app is initialized. We'll see what that means, but it means setting any default values that you might need, initializing an application in really the generic sense. But then the real magic happens in this bottom left quadrant, whereby thereafter your program essentially sits there in a loop, an event loop, just waiting and waiting and waiting for stuff to happen. Is dying. So the NS array here. So this actually just for warm-up's sake. On the left-hand side of the expression, could someone just say in somewhat technical English what this expression here is doing for us? Just to get the jargon down, especially for those who are rusty or unfamiliar up till last week with C. Yeah? OK, creating an array of names. So not quite. Let's be a little more precise, only looking at the left-hand side. So right track, but you're over-interpreting the left-hand side there. So OK, so we're declaring a pointer to really an object of type NS array. So what that really is doing is giving me only 64 bits, a memory address space that currently doesn't point to anything. It's some garbage value until the right-hand side of the operation, where we then see the name of that class again, NS array. Array with objects is apparently a method defined inside of there, and it takes an argument, which is a comma-separated list of objects to add by default to this array. So this, put it more precisely, we are passing on the right-hand side of the equal sign the message array with objects with that argument to what or to whom? To the NSArray class. So that suggests that array with objects is an instance method or a class method. So it's class method, which means in its header file or somewhere it's declared with the plus sign, which was the syntactic detail we saw last week that says this is a class method or a static method in the world of Java, whereas if it were a minus sign, it would be instance method. And for those less familiar, the fact that it's a class method simply means, again, that we can invoke it without having instantiated any objects yet. So this is more generally known in iOS as, or in Objective-C as, a convenience method. We don't have to call alloc and then init. We can just say what we want, array with objects, and whoever implemented that method actually is going to call alloc in there for us. All right, so nil, this is a common mistake. Silly though it is, you do have to nil terminate any statically allocated arrays in this fashion, so don't leave that off. Xcode will warn you or yell at you if you do not. So at this point in the story, I now have some kind of array structure in memory that's got two elements in it. All right, so the next line is just an example of what Objective-C calls fast enumeration. So it's just a loop that on every iteration updates the pointer called name to be the current element in that particular array. And NSLog is sort of our printf-like friend that's just going to print the person's name to the screen. And so just to run this, Command R is going to open the debugging output window on the bottom. And in the bottom here, happen, and that stuff might be induced by the user interacting with the glass of the screen and touching something, thereby triggering an event that your loop is forever listening for, or it might be that the clock strikes midnight and your app all of a sudden must do something, and so that will be detected as part of this loop. But for the most part, we'll understand after tonight all of the steps leading up to that, and then how to start configuring this loop to actually do interesting things. Respond to button key presses, respond to sliding the finger across the screen, respond responding to pinch events and the like. All of that's going to be handled there. And then along the way, we'll find that each of these steps sometimes itself sends messages to other objects to let you know that this step is done. This step is done. Case in point, as soon as the app has been initialized, it sends this message, application did finish launching with options. And this is a rather verbosely named method, but that's going to be a message passed to you so that you can then take control of the application, do any additional initialization that you might want to do, and the like. So ultimately, though, this picture pretty much captures what happens up until the point where things quit, at which point you switch to a different app entirely. All right. So what are some of the capitalized expressions we're about to see? So there's going to be UI application. This is a class that refers to exactly that, the application that you're writing. UI application delegate, in more real terms, this is the class. This is the guy that will be instantiated once for you that's going to take control of the application after that C function, UI application main, gets invoked. So we will be writing some code, though not much generally, in the UI application delegate. Then let me skip ahead to UI view controller. So iOS conforms to the MVC model view controller, much like Android. And what this generally means is that you're going to have a controller, otherwise known in the iOS world as view controller. And it is what's controlling what the user sees on the screen and also where data is coming from. So it's going to talk to the models that you yourself might write, to a database of some sort, to an internet connection, and it's going to then present information somehow through what we'll call a UI view. And there's going to be all sorts of UI views. At its most generic, a UI view is just a rectangular portion of the screen. But more interestingly, we'll have UI view subclasses like UI button, UI text field, UI label, little GUI widgets that will be layered on top of otherwise this very generic rectangle. And that's how we'll create, among other ways, our user interface. And then we'll see things like UI window, which pretty much refers to the topmost notion of a screen, to the glass. You can think of it in that way, but it has some methods associated with it. So in terms of the mental model to have, much like Android, think of the iOS world that we're about to dive into as this picture here, whereby we are going to be writing lots of code in controllers, more specifically known as view controllers. We're definitely going to be writing a bunch of views, even tonight. And now, by writing views, we'll sometimes do it via a nice drag and drop interface. Doesn't all have to be code, doesn't have to be XML files. And you'll find that Interface Builder is a bit more sophisticated than the Android counterpart right now. We won't dive so much into models just yet, but that, of course, is where data might come from, or how you model your real-world entities. But again, notice what is absent from this picture is any kind of crosstalk between these two. So it really is the controller that's meant to be the brains behind any operation that we're implementing. So templates. When we launched Xcode last week, we saw a whole bunch of templates, and we kept choosing the command line template for Mac OS because we only played with a whole bunch of student demos, and we'll do a couple more just to reflect back on some of the syntax and features of Objective-C that we played with last week. But now that we're going to be clicking under the iOS submenu, we're going to get some more sophisticated templates that are going to give us more code to begin with than just a main.c file. And one of the downsides I felt of learning Objective-C and Xcode early on is that these templates tend to hide certain details, especially details related to the GUI. And so what we'll try to do tonight in particular is make sure that when you start with any of these templates, in particular the single view and the utility application this week or next, that you understand exactly how everything is wired together, what you're getting for free out of the box, so that it's not any kind of dark magic, but so that you yourself could actually take everything apart, or even just start from truly a clean slate, an empty application, and wire things together. So just realize that I think a lot of the mental hurdles that at least I faced in learning this stuff early on was just not understanding what the tool was doing for me, and because it wasn't really telling me, unless you actually read through all of the comments and you poke around a lot. So I'll try to hold our hands during that so that you can more quickly dive in than I once did. All right. So, any questions about where we are headed? Or any questions from last week? Let me see if I can generate some questions from last week. So here is students 8. We didn't see this last week, and the comments rather reveal what this does. This demonstrates immutable arrays. So an immutable array is just one that can't change. So you have to know its contents in advance. So in this case, let's see what I have done, just so we, again, can get back into the swing of things syntactically of Objective-C. So for now, we have this thing called auto release pool. I'm going to use my old school finger tonight since the green